The next 30 minutes, we're going to hear from Mr. Jason to talk about Python feature, the Metaclass. Let's have a warm welcome.
Oh, thank you so much. Oh, wow. It's going to take getting used to hearing that. No, I love the fact that I got booked for like the last slot here because I'm covering metaclasses. And now I get everyone when they're half asleep and somewhat sleep deprived. And that's the cool part. So that's awesome. So raise your hands if you feel you have an understanding of what a metaclass is. Okay, yeah, it's about 37% or so, which incidentally is the same percentage as lies on their resume. Just bit of a coincidence that. No, I mean, none of us really understand the metaclasses. I don't even fully understand metaclasses, to be honest, so I'm going to spend the next 30 minutes of your life explaining them to you. Don't try to leave, we've sealed the doors. A lot of the explanation I'm going to give is coming from my book, Dead Simple Python, which is available from No Starch Press. I cover all of the core features of the language, including metaclasses. And the cool thing is, it's nearly 700 pages, so you can also use it to knock out anyone who disagrees with you. It's multi-purpose in that regard. I often get asked, how did you write a book called Dead Simple Python and cover metaclasses? Well, it's not really simple looking into it, but once you understand the principle and you look back, you go, oh, is that all? So hopefully that'll be your experience here today. But this book is great if you feel you understand Python to some degree and you want to understand what Pythonic is deeply. Check this out. Okay. By the way, I just noticed my clock isn't running. I don't know if anybody intended to turn that on. Thank you. Okay, cool. Yes. All right. So what are metaclasses? We'll start there. Let's go all the way back to CS 101. You know, when you first learned programming on, college or from Udemy or Al Sweigert's book or whatever. What is a class? Well, you can think of a blueprint. You draw a blueprint of a house, and then you can build a house. Okay. You can build two houses. You can build multiple houses from it. And each house you build will look like the blueprint. If you change the blueprint, then each house you create from that blueprint from now on will be different. But if you change one of the houses, you're only changing that one house. It's not affecting the others. Okay, this is pretty basic. Blueprints are classes, houses are objects. Cool. All right. Well, in Python, we say everything is an object. Okay. Well, that's nice and glib and compact. And so what's a class? Apparently a class is also an object. It's turtles all the way down. Well, actually, if you think about it, a blueprint is an object. You can pick up a blueprint. You can hand it to someone else. You can have two blueprints. You could have three blueprints. They're all different. You make a change to one blueprint. It doesn't change the other one. All of these are built from a template. You have a template blueprint. If you modify that template to, say, use meters instead of feet, then that's going to affect all the blueprints you create on it from then on. So those classes are actually still objects. They're instances of the metaclass, which is the template. So we can have a lot of different templates. We most commonly use the built-in default one in Python, but we can have different templates, and that'll change how we create classes. Okay, so our basic template, our basic metaclass is called type. You've been using it this whole time. In fact, in the original proposal, someone had said maybe we should just call these types, and someone said that would be too confusing. Let's call it a metaclass, and we've been confused. Oh, sorry. And we have been confused ever since, so cool. But every time you want to create a metaclass, you're inheriting from type. It's the prototypical metaclass. You instantiate the metaclass type, you get a class. You might remember from Python 2, we always inherit classes from object by default. Back in Python 2, we had to do that every single time. We no longer have to. But object is still kind of the prototypical class of Python. And then, of course, we can instantiate our class and get an object. So to address the elephant in the room, Tim Peters said, metaclasses are deeper magic than 99% of users should ever worry about. If you wonder whether you need them, you don't. The people who actually need them know with certainty that they need them and don't need an explanation about why. Thanks for coming to my talk. No, that is not... We often stop there and think, okay, cool, so I can just move on. But we have to understand what a metaclass is and what it does so that we can evaluate using our spidey sense as Python developers, or maybe that's our Python sense, I don't know. Terrible joke, I heard that. Whether we're supposed to use metaclasses. So let's talk about what metaclasses actually do. All well and good to say they're templates, but there's 4 basic things a metaclass manages in Python. The first is class instantiation. That is class definition, when you define a class. And so you have methods like Dunder call and Dunder new. These are defined on the metaclass, by the way, not to be confused with the ones you've been defining on your classes this whole time for objects, but same purpose, same principle. They handle class attribute storage. How are class methods and class attributes stored? You can change that, and there are some cases where that's useful. It handles the method resolution order, or MRO. By the way, I think that is the only built-in special method in Python that does not have double underscores. Fun fact. And then it handles inheritance. So Dunder instance check, Dunder subclass check is kind of a way of adopting a class and saying, well, this class is sort of like one of my children, but it doesn't actually inherit from me. And abstract base classes use this. So I'll go into each of these. Before I do, briefly, what happens when we actually create a class? First, the class method of metaclass, that part takes a minute to load into your brain. So on the template, on the metaclass, you have a quote-unquote class method. You have call defined in the metaclass. That is the thing that then calls first prepare, still a class method. That's going to set up what's called the namespace. This is where we're going to pack all of our class attributes and class methods. Don't worry, I'll come back to that. Then we call the new and the init, the Dunder new and Dunder init methods on the class now, which are instance methods on the metaclass. By that point, we have a class object in Python. And we can now instantiate that class. So to do that, we call Dunder call on the class. You see that all the time when you have the name of your object and the little parentheses after it. That's what it's invoking, is class call. And then that calls new and init on the class itself to instantiate. So you see, it's basically the same between the two. The only real difference is that a metaclass has this prepare method there in the middle. I'll leave that up for just a moment longer because that one can take a minute to get used to. I see a bunch of people photographing it. Okay. So let's look at some practical use cases of this to kind of put this into action. Use case number 1 is Singletons, which you learned the first time you read Gang of Four, and you thought that is so cool. And you used it everywhere. And then your mentor finally said, "What are you doing? No one uses Singletons, stop it." And then you never used it for the next 10 years of your life. And then we had that brief moment in the sun in Python where we had class properties, because properties are cool. You know, you can define. It looks like a class attribute or an attribute, and you can work with it. It's beautiful. And for a brief moment, one version, we actually had class properties, and then we discovered they didn't work the way we expected, and we took them back out again. I was just so disappointed. Well, singletons allow us to effectively work around this because we can write an object with all the cool stuff, properties or whatever, and make sure we only instantiate it once. Okay, yes, you could just do a global shared instance, but who's to stop you from accidentally creating 2 or 3? I have. So a singleton can be useful when you need that shared state and you want all the fancy features of an object and you don't want to accidentally create 2 of them. To create a singleton in Python, we use a metaclass. We're going to create a metaclass called Singleton. We're inheriting from type. This is what makes us a metaclass. We have an attribute, a metaclass attribute called Dunder instance. I could have also stuck this on the class if I wanted, but you'll see that later. But this actually does work. I tested. And then you define Dunder call. So this is the beginning of instantiating a class. Excuse me, instantiating an object. Takes a minute to remember that, but an instance method on a metaclass is a class method on a class. Takes a minute to get used to that. So this call method is what would be called when we try and instantiate a class that uses this metaclass. And we check if the instance already exists. If it does, we just return it. Otherwise, we're going to instantiate a new one. We super the call, create the new instance, store it, return it, all's good. So we're going to use that. We define a class once. We say metaclass equals singleton in the inheritance there. So that is defining that we are going to use the singleton metaclass. Otherwise, we're making another metaclass. So metaclass equals is important. And then we can do whatever we want in that class. So if I instantiate that, I'm only ever getting one instance. If I try to instantiate again, I'm getting the same instance as before. You could build on this. I've seen versions of this that allow reinstantiation, overwriting the instance. You can do different things with it. But this is the basic singleton in Python using a metaclass. All right, use case 2, controlling class methods. There's a few reasons why you might want to do this. Maybe you want to apply a decorator to every single class method. Save yourself some time. Or maybe you want to validate that class methods are following certain conventions, or you want to prevent some class methods. In other words, this is as close as Python gets to compiler time errors. You don't usually need this, but every now and then. So let's say we have a metaclass called unaddable, and we want to prevent the definition of Dunder add. We don't want it to fail when we instantiate an object or when we try to call Dunder add. We literally just don't want any classes using this metaclass that have Dunder add defined at all. So we use the Dunder new method and we check attributes for something called Dunder add. And if it's there, we raise a type error. Otherwise, we pass it on. We super the call. Okay, so I'm going to define a class using that metaclass, call it misbehaving. Oops, there's my Dunder add method. Now, as soon as I run this code, note I haven't instantiated anything. Well, the class itself has been instantiated off the metaclass, but I haven't instantiated any objects. We get a type error immediately as soon as I run the code at all. So this is actually a way of doing effectively what you might think of as compile time. We don't really compile, but this is like compile time checking. Use sparingly, but this can be helpful to catch really crucial, do really crucial verification that you're not defining something you're not supposed to, or that you're following a critical convention that would result in a horrible bug if you overlooked. All right, use case number 3, class namespace. So in Python, we typically store everything in a class or everything in an object in a dictionary, which is all well and good, but sometimes you want to store it a little differently. Who here has used the enum in Python? Okay, so Enum is made possible by that code. I pulled that right out of the source code of Python, just pulled the comments out of it. That is how enums actually work. It overrides the dictionary that stores those class attributes. Because think about what an enum really looks like. It's just a class with a bunch of class attributes. No member functions, just class attributes. And yet it does all this magical stuff. And that's because we're using this class method prepare on the metaclass to change how those class attributes are being stored. There are some libraries that will use an ordered dictionary to make sure that the order is preserved. I don't see prepare used too often, but the times it creates some pretty neat stuff. Now, the reason I use this example is because I took 2 days to try and write one, and it was hard. So it is difficult, here be dragons, but when you need it, you need it. All right, use case number 4, manipulating the MRO. In case you don't know what the MRO is, this is the method resolution order. It is how Python determines where to look for anything you're calling on an object. I have another talk on my website that you can check out from a few years ago in which I explained the method resolution order, but to give you the super simple version, we would check the object itself, then we would check its immediate parent, and then its immediate parent, and we keep walking our way backward until we reach object. The MRO gets really interesting when you start talking about multiple inheritance. I won't go into that here. But what if you needed to change that behavior? What if you needed to check things in a different order? We can actually do that with metaclasses. So consider a class called arcana, and we have some things defined in there. Most notably, we have a magic word function. I want to be able to have my class look at this as an absolute last resort. I don't want to override anything, not even an object. But if it's not anywhere at all, I want to check here last. One way to do that is to define a metaclass and change the method resolution order. I am using the existing one. You see me unpacking super MRO. So that's the default method resolution order for this class. And then I'm adding arcana on the end. So I'm not inheriting from it at any time. After I check everything, including object, then I check arcana last. So I use that, and the class definition is unimportant here, because if I call magic word, it finds it. But if I try to use repr to get the string representation, notice it's getting the string representation from object, not from arcana. So I have changed the method resolution order. Again, something you will very rarely need to do, but when you need it, you need it. Last, but probably most useful, is whenever you need class Dunder methods. I learned this the hard way. Let's say I'm writing, and by the way, this is really contrived, warning, this is really contrived code because I wanted to fit it onto the slide, but I did do something similar to this in real life. That was less contrived. Let's say you want to control how you're accessing class attributes. Well, you would think, okay, I can just override the Dunder get adder. Oh, but it's not on the object, right? It's on the class. So I got to make it a class method, okay? It seems pretty reasonable, except as soon as you try to use this, it doesn't actually work. If you want to override a lot of the Dunder methods on a class, you actually need to define them on the Metaclass. So here's a data dictionary. Metaclass that I've defined. I am adding a class attribute. There's prepare. One of the uses for it that's more common is you can stick some class attributes in early on. So I'm putting a mutable dictionary in there. And then I have my Dunder get adder method. So this is a class method, or method on the class, excuse me. And basically what I'm doing here is I'm allowing passing a dictionary to store. And then I'm replacing all the spaces with underscores. And I'm allowing, when I try to access an attribute, I am checking for I'm checking for a value in mutable dictionary if the normal attribute lookup does not work. Again, contrived. But I did do something similar in real life. So to actually use it, I use the .addict metaclass, and now it actually works. I can actually access Bob_Smith, which came from that dictionary. I will come back around to what happened with this real world case, by the way, because it did not go as expected. But one more example is the abstract base class. Every time you use an abstract base class, you are using a metaclass. This is, again, the Python source code. ABC meta is the metaclass that defines an abstract base class, and the most crucial part of it is Dunder instance check and Dunder subclass check, because, again, it's sort of adopting the collection abstract base class. You can use a string that fulfills the collection interface. It fulfills the criteria for collection, I believe, sequence in any case. But it never inherits from it because it's using Dunder's instance check, Dunder subclass check to say, hey, by the way, that string object over there, that's my adopted kid, okay? It's not anywhere in my actual inheritance order. It doesn't actually inherit from me, but let's just say that's my kid. That's how that works. So when you define an abstract base class of your own, which usually you can just inherit, you can use the ABC meta, I won't go into that, but when you define your own abstract base classes, you can say all of these classes that I did not write fulfill the interface that I am describing here. So I said I would be coming back around to that dotted dictionary thing. In real life, I had I was working on a test framework at a previous job, and I needed to be able to monkey patch external resources, files, system calls, API responses that simply would not exist in the testing environment. It was impossible to get them there. So I needed to be able to provide these easily. So my first thought was, okay, well, I want to store these. I can't remember exactly how I did it, but I wanted to store these in a way that I could easily access them from all the tests. So I kind of came up with something similar to that dotted dictionary. So I could provide this huge blob of information in a dictionary, and then that could be loaded in and accessed like attributes. Worked great, actually. Until a coworker goes, well, why are you using metaclasses? That's too complicated. You shouldn't use that. And my staff mentor at the time, Patrick Viafor, said, well, actually, metaclasses are the right way to solve that problem. But you're solving the wrong problem. And he helped me see that actually there was a much simpler way to go about thinking about what I was trying to do. And again, it's been a few years. I can't remember exactly how. But there was something that was a lot simpler that didn't require me to touch metaclasses at all. The moral of the story being, if you think you need something advanced like a metaclass, the first thing to ask yourself is, what am I trying to accomplish? Is there a simpler way to get there? Is there a simpler problem to solve? Solve the simplest problem you can. If that problem is unsolvable, then you move on to the next simplest. If you have that frame of reference, then you will not easily get lost in trying to use metaclasses where they're not needed. But sometimes when the stars align and the moon is in the right phase and the seagulls are approximately around your office at just the right angle, you need metaclasses. And when you do, they're there. Because it's just one of the things that makes Python cool. Thank you.
Please use the microphone over there. for any questions.
Hello.
Hi.
Number one, great talk.
Thank you.
Just one quick question. So you mentioned that like enums and abstract-based classes, they're also metaclasses. Why is it that when we instantiate them, we don't need metaclass equal?
Great question. So once you have defined a class that has that metaclass equals, it defines I'm using this metaclass, then every class that inherits from it also inherits that metaclass. So it's a little bit like saying, this is my template for this class. Now let's make another class, make it look like that one. And Python automatically grabs the same template, which does lead me to add, if you start doing multiple inheritance, don't mix your metaclasses because it gets really weird.
It's actually a perfect segue to my question. Like, let's say, if an enum is a metaclass under the hood and I want to change some of this behavior of enum, like let's say when I instantiate it, I want to grab some information from elsewhere about what the contents of that enum should be. Should I just not do that, or?
There's a few ways you could solve that. One would be to inherit from the metaclass, like make a new metaclass inheriting from that enum metaclass and then override the behavior the same way you would with a normal Python class that you want to augment its behavior. The second could be classic composition, where you're defining a new metaclass or even just a new class, depending on what you're needing to override, that has an enum in it that uses an enum. Those are both valid approaches. Which one is right for your case would be a very specific thing you'd have to figure out.
Awesome, thanks.
Yeah.
Yeah, thanks for the great talk. Your second example about checking for the Dunder add shouldn't be present. Wouldn't it be easier to use a class decorator instead of a meta class? You can achieve the same thing, I think.
The check.
Second example, the check.
Yeah, this one here. Yeah, you can. Can you repeat what the alternative was that you were thinking?
You can use a class decorator. A class decorator, you get the class, and then you can check for the attribute Dunder add, and if it exists, then you throw an exception. This is much shorter, and you don't need to involve meta classes.
See, solving the right problem. Yes, that is true. This is painfully contrived. But there are cases where that check starts becoming very complicated and where this can be very useful. So I picked something super short that fit on the slide, but you're right. There is a simpler way to do that particular thing. So sometimes, trying to solve it without the meta class is often a good idea because, again, most of the time it's not the right tool for the job. But at a certain point of complexity, you start getting that sense that I think I'm fighting against the language. And that's when it might be good to pull back to something a little more robust like this. So again, that line can be hard to gauge, but thank you. Yeah, that's valid. It is really hard to come up with one example of metaclasses. 5 was harder, which is I think ultimately why Tim Peters said what he said, because no one wanted to come up with an example for this. Can't blame them.
Hi, thanks for the talk. From my understanding, Google protocol buffer uses metaclasses.
I believe you're right. Yeah,
And you can kind of so you can't change your types or delete attributes. Keep the structure sort of static.
Yeah. As soon as you encounter something that seems to be behaving, it seems to be controlling the class attributes or the class functionality, you're probably dealing with a metaclass at that point. Yeah. Metaclasses show up in Django. They've shown up in FastAPI, I believe. I'm sure Sebastian can correct me. They definitely show up in Flask. They show up in a lot of data libraries because, again, they let you control the class behavior to a degree that you can augment it and make all sorts of magic things happen.
Okay. Any more questions? Cool. If no, I think this wrap up for the final session here. And thank you, everyone. Let's have another warm welcome to Mr. Jason. And the lightning talk is after 15 minutes. Thank you, everyone.